For this video, we are going to talk about our first projectile motion problem. To start with projectile motion, there are two key points that we must understand. The first one is that x and y components are independent of each other. If there is a velocity that is in the x component, that velocity is going to remain unchanged throughout the problem. There is nothing that is affecting that velocity. There is no acceleration, deceleration, or anything else. So whatever your velocity is in the x plane is going to remain constant. Things that will be changing will be in the y plane. Your velocity in the y or your distance in your y are going to be changing as the problem continues. But they are both independent of each other. The other key point for this is that time is the one constant go between the two x and y components. So whatever the time is for the object to fall, if it were in straight free fall, is the same time that it'll be traveling to the right for this particular problem. All right, so let's keep those in mind as we go and try to solve the problem below. Here it says a car traveling at a constant speed of 13 meters per second drives off a cliff that is 77 meters tall. How far from the base of the cliff does it land? According to the problem-solving process, I want to read it again and then take out the values that are provided in order to solve. So I know my velocity in the x is equal to 13 meters per second. I know that my distance in the y, or change in y, is equal to 77 meters. Now I'm going to draw myself a picture. Here's my car. Super fast. 13 meters per second. And it falls off the cliff and winds up somewhere down here at the bottom. In order to find my change in x, I already know my speed. I have to find the time that it's traveling here. So time is the constant between the two. I know how high the cliff is. So if I go back and I remember that x is equal to 1/2 at squared, the time it takes to fall can be solved by knowing how far it falls forward. The fact that it's moving 13 meters per second to the right is independent of the time it takes for it to fall straight down. So rearranging my equation in order to solve for t, I have 2x over acceleration due to gravity, all under the radical, is equal to t. So I plug in the variables provided. So 2 times 77 meters divided by 10 meters per second squared, all under the radical, equals my time of 3.92 seconds. So now I know time equals 3.92 seconds. Now when I was falling straight down, it was also moving to the right. And every second it moved 13 meters to the right. So average velocity is equal to the change in distance divided by the change in time. So if I'm looking for the change in distance in the x, x is just equal to average velocity times time. So in the end, when I'm looking to solve for how far from the base, I just multiply my constant velocity of 13 meters per second times my time interval of 3.92 seconds. And my answer is going to be 50.96 meters to solve for the range.